Hey guys, welcome back to my channel. In this video, we'll be talking about machine learning and we'll also build our first basic machine learning model using TensorFlow. This is going to be a pretty interesting model. We'll be going through what happens behind the code we do and how the machine learning model behaves and how it learns. So let's get started. So in this presentation, I'm going to give some insights on machine learning and what goes behind the codes. By the end of the presentation, you will understand what is machine learning and its application. You will understand how it is created, and we will also be using modules like NumPy, Matplotlib that we saw in previous tutorials. The machine learning framework that we'll be using is TensorFlow, developed by Google, and anyone can use this. You do not need any previous knowledge on machine learning. This will cover from basics, and I'll go as in depth as possible to give you a good idea of what we are coding. When we go to the coding part, you will be able to understand that this is what we are coding and what goes behind our codes. By the end of this presentation, you will get a basic intuition of machine learning. You'll also get to know the difference between machine learning, deep learning, and artificial intelligence. So let's get started. So what is the difference between machine learning, artificial intelligence, and deep learning? Okay, so let us say that this circle right here is artificial intelligence. Okay, anything that is going to mimic a human behavior or automated task is AI, and this circle right here is machine learning. Okay, what is the difference between AI and machine learning? Machine learning is a part of artificial intelligence, but here in AI we have it is rule based. In machine learning, the computer learns the rule. And what is deep learning? Here, right here, this is deep learning. It is a subpart of machine learning. Okay, so a machine learning has one hidden layer and deep learning will have two or more hidden layers. You will understand what is deep learning when we are going through the next few parts. So let me scroll down, and here is a chart. We are going to basically see the difference between machine learning and deep learning. So these green color boxes are the inputs. This is the program and this is the output. In conventional programming, what we have to give as input is we have to give rules and data, and this will take this is conventional programming, and it will give the output, that is answers. Whereas in machine learning, you give the data and the answers. This is machine learning. When you feed a data and the answer to a machine learning model, it is going to give you rules. Okay, then later you can use this model, what we have created, the model that we create using machine learning, and then you can feed in data to get answers. So this is the difference between conventional programming and machine learning. You cannot create all rules for everything. Like, you cannot keep creating rules for an automobile, for an autonomous vehicle, because there are n number of rules. There is not only one road sign. The road sign differs from country to country, and there are various animals that it has to do that. So you cannot hardcode all the rules into a conventional program to get a good result. So in that case, you will be using machine learning model. There are different types of machine learning. So the major three types of machine learning is unsupervised learning, supervised learning, and then reinforcement learning. Under unsupervised learning, we have two different parts. dimensional redirection, and clustering. Under this we have again two parts, classification and regression. And then under reinforcement learning we do not have any subparts. The reinforcement learning is used to build game AI, robo navigation, skill acquisition, learning task, real-time decisions. Okay, let us talk about how the reinforcement learning actually makes game AI, how game AI is created. Let's say you are playing a racing game. Do you think all your opponents in the racing game is just they are just hard coded? Do you think some other person have drove the car and then they got a timing and the car travels in the same road and same path every time? No, it doesn't happen like that. So if you go and hit a car, it comes back to normal. You cannot hardcore whenever I get hit. You have to bring back to the same path and you have to make me travel, something like that. So game AI is usually done using reinforcement learning. All the bots in a game are made using reinforcement learning, and how good these bots can be are trained based on the number of times they run through the game and they learn more. So if they are running for, let's say, 2 days, if a car is learning to go around a track, then it is going to learn so good that it will not let you beat it. It is going to be a pro level. If you keep the level at ease, then it is going to be a bot that is very dumb, that makes a lot of mistakes, that is not trained well. And then robot navigation, yes, these are done in simulations. Skill acquisitions, there's something called OpenAI Gym. If you are interested in reinforcement learning, you guys should definitely check this OpenAI Gym. There are a number of games and you can create your own model there. It's pretty cool that you can see some reinforcement learning model just learning by itself, even from basic. It's like a kid, it's like a child's brain, and then it is learning by failing again and again. So these are some of the applications of reinforcement learning. And then under supervised learning, so supervised learning is what we will be going through a lot. Under supervised learning we have two types, we have classification and we have regression. Okay, what is classification? You want to classify something based on the appearance or based on the features, and you are going to classify between them, just like if whether it is a cat or dog. Okay, so you given images of cat or dog and then you want to classify whether it is class or cat or dog. So this is a very good example of classification. This can be used for diagnostics, cancer detection, yeah, and so much things like this. So image classification for autonomous cars. Why we need image classification? We need to classify based on the appearance, whether it is car, bike, pedestrian, etc. So identity fraud detection, so same thing, you are going to give images of fake ID and real ID, and then it has to classify whether the ID is fake or whether the ID is real. So if you can train many models according to the applications you want. This is just an example of applications. There is n number of applications for classification problem. And then we have regression. Under regression we just get values like you can tell if you want to get values between 0 and 1. Okay, let's say that you are predicting the price of a house. Okay, now the price of the house can be anywhere from 0 to maybe a million. So this and all comes under regression. So it is not this or that, it is basically it has to understand which price range it has to be in. So weather forecast, it comes under regression because you want to estimate the time when the clouds will reach a particular place and whether it will rain or not. So rain or not is more kind of in classification, but you want the timing, right? So the timing or things like how much it will rain. So this and all comes under weather forecast, under regression, market forecast. Yeah, you can predict whether a stock will go up or a stock will go down using regression. And population growth prediction is another example of a regression type. Estimating life expectancy. So you give a complete medical statement of a person, how many times they had heart attack, what is the weight, what is their height. You give everything to a model and it will be able to predict the life expectancy. So that is, this and all comes under regression. And under unsupervised learning we have clustering and dimensional regression. Let's say you have n number of customers coming into your coming into your store, and then they are leaving. Now you want to identify the customers who is going to buy your product, who will be interested in your product. Let's say that you have a store in which you sell all expensive items. You only sell expensive clothing or something. So based on their image or what they wear, you will be, yeah, you cannot judge a book by its cover, but still I'm just giving a very lame example. Based on the customers, you can have your staff go to them, talk to them, interact well, and then you can make them buy some stuff. This is very much important for online marketing. You get a lot of data online. If you go to you can actually get more data. If whenever you are signing in something, they ask your age, they ask your region, where you're from, and all these things can really help sellers will now post their advertisements, and these advertisements will be targeted to particular people. Let's say you want to sell something for teenagers, okay? So you want to target these advertisements towards only teenagers, okay? So this kind of marketing strategy is called targeted marketing, and it is basically done with unsupervised learning. And then you have customer segmentation. Okay, that's a very bad spelling, but it's customer segmentation. Yeah, as I told you, similar to targeted marketing, customer segmentation, then recommender systems, all this comes under clustering. Let's go and let's talk about supervised learning. Okay, so what are the steps you want to do to, how will you implement a supervised learning model? So here, to implement a supervised learning model, first we need to collect data. Okay, whatever data we have, we need to collect it. So it's called data collection. Okay, and then we are going to do data cleaning. This is a very important step in any learning, because you don't want ton of photos named as dogs, but they are actually cats. So you will train the model wrongly. If you have very less data that is not categorized properly or that is not proper, then it's okay. But if you are having a large number of data that is improper data must be removed. So that is called data cleaning. Then you split this data as test data and train data. Here, after you split this data, you are going to do model training. Okay, if it doesn't make any sense to you now, just calm down. We'll go through this one by one. So first you have to get data, and then you are going to do data cleaning. And then after you clean the data, after you make sure that your data is good enough for the model to be trained, then you split the data into two parts, that is test and train, and then using the training data alone, you are going to feed this training data alone to the model. Okay, what is a model? We'll go to how a model can be made and what is a model, but you will use only the training data to make the rules. Okay, and then we get model testing. Okay, using the model that you have created now, you want to test how well it performs. Okay, so that is called model testing, and then we have to go for model deployment. This is very crucial if you want to work for any company. Okay, so after you make sure that whatever model you have created is satisfactory, then you have to convert it into an app and make an application out of it. Okay, or maybe use it in a website or something. So that is where model deployment comes in. And when you're at this stage, model deployment, you use both your train plus test data. So you run everything, all these steps: data acquisition, data cleaning. Then other than splitting it to test data and train data, you use both the test and the train data when you want to deploy a model, because a model can get better if you feed in more data. It needs more. If you give more data, means it is going to get trained very well. So that's why you need more data for model deployment. And then we are going to talk about how this data is split. Okay, and then in conventional splitting data splitting methods, it will be basically split into two parts. This is train data. As I said, this is train data and this is test data. So it will be split mostly in the ratio of 70:30. Okay, 70% will be train data and 30% will be test data. And sometimes you get train data, validation data, and then test data. Why do you need to go for this method? Okay, when you are training without a validation set, what happens to the model is there's a problem called overfitting. Okay, if you use this method, you will get into this problem, overfitting. But if you use this method, you will know if it is overfitting or not. Okay, so every time this model is getting trained, it will check with the validation data whether it is able to predict properly, and it can get an accuracy and loss. Every time it is training, it is going to do this with validation data. This data will be unseen data. This will be leaked data. That's how I usually call this data. So this data will be used for validation purpose to make sure that it is getting trained properly. So this data is going to be completely unseen data. This is going to be the data which you will use to evaluate the model. So this is how the data is split conventionally. But nowadays we have a lot of data. This data is okay if you have data like, let's say you have 10,000 data points. Okay, this is okay. But nowadays we have millions and millions of data points. If you want to get a good model, you need more data, and people are always collecting data. Whatever data we have, we can use all of that data to train a model. So when you have tons of data, let's say 1 million data points, then you split it in this percentage. This will be 98% of trained data. This small box right here will be just 1% validation data. and this we can use for testing just 1%. When you have a lot of data, you can do this. Okay, let's say what is a neural network. So this is a simple diagram of a neural network. This might look very intimidating at the beginning, but it's pretty simple and straightforward. So this is called input layer. This is where we give features. Okay, this is feature 1, feature 2. What are the features? Let's say you want to detect the price of the house. Okay, in the end you want to estimate price. So what are the features that you need inside this? Is you need number of rooms, yeah, and then you need number of bathrooms, square feet of rooms, square feet of house. These all things can be a feature of the house. The price can vary according to these features. Obviously, if the number of rooms are more, then the price will go more. If the square feet of the house is more, the price will go up. So if the square feet of the house is what makes this very important, then this will have a weight. This will have more weight. Okay, we'll talk about weight and all later. Now, if this is more important, then the machine learning algorithm will understand that square feet of the house is the most important parameter or feature that we have to take into consideration to predict the price of the house. Okay, so there will be a number of features. According to the data set, you can create the input layer. Okay, if you have 30 features, then you need 30 input layer, and then these all are hidden layer. Okay, this is where the magic happens. This is literally like a black box. Okay, this entire thing is like a black box. The equation will be created based on this, and all the things that happens inside this, you can of course see them, but let me go and explain how this thing works. Okay, let's take only one perceptron, only this circle right here. Okay, here we have feature n number of feature. Let's say x, y, and z. Okay, this is feature 1, this is feature 2, this is feature 3. This goes to input layer, to the neural network. Okay, this goes to input layer of neural network. These three inputs will have weights w1, w2, and w3. Okay, and what happens is, here, right here, this is a neural network. It is nothing but summation of xi, or all these inputs. Okay, let's say this is x1, this is x2, this is x3. The summation of xi, wi. Okay, that's all this neural network is. And apart from this equation, apart from the neural network, it also has something called bias and an activation function. Let's see what is a bias, why you need it. Let's say one of the features right here is giving you 0. Okay, it's not very let's say that feature is not very important. That feature is like whether the house has a pot or not, whether the house has a TV or not. Okay, that feature is not important for the prediction of house price. Okay, so that feature will get a weight of 0, right? Because it is not very important. But this 0 will make this entire neural network 0. And when you have multiple neural network layer, when something is 0, then the entire thing becomes 0, right? Then 0 will mess up the entire neural network structure. So what you have to do is, you need something called bias, b, that is equal to, let's say for now that it is 1. Okay, this is also varying when you train a neural network, but let's say a bias is added now. This makes sure that the neural network doesn't collapse with just zeros all over the place. Okay, so that is why we have bias, and this equation becomes plus b. You might be wondering, what is x now, what is w now? These are the, as I said, these are the inputs and the weights of the neural network. Okay, so xi will be represented as a matrix. Let's say the matrix is 1 point, it cannot be above, okay, 0 0.9, 0 0.8 and 0 0.7, and then the wi is going to be something like 0 0.2, 0 0.5, 0 0.7. Okay, so this is how it is going to be represented inside a neural network. And then plus b, let's say it is 1 1 1. Okay, it is just going to be single one. Okay, and this is how the neural network works on the outside. This is very similar to human brain. I have an image of a human brain. So here you can see it collects data, not data actually. You cannot, in the modern term, you cannot say that it is similar to a human brain, because there is more that goes on a human brain, on a neuron in a brain, than a mathematical model. This is more of a chemical model. There's a lot we don't even understand till now about how our brain works. But to be, let's say you're touching something hot, okay, and then this signals a cell inside, and that gives a signal to the next layer, to the next neuron. Okay, and then it sends, and then it eventually reaches to brain. So that's how a neural network, a single neuron, will work. It's called perceptron. If you guys don't understand any of this, it's fine. You can simply, you don't need maths in order to make machine learning models. I'm just telling how everything go behind the code. Okay, it's going to be pretty simple. It's not this intimidating. This entire thing right here, this entire model can be created within 10 lines. Okay, and let's go ahead and see what is activation function. So this till now what I said, it's a perceptron. So let's say that is this part. Okay, you cover half of what is perceptron, you need the other half. This is called activation function. Simply to put it in term, when you have something large and when you multiply it with weight, that is large, okay, w large, it becomes so large, and when you do this n number of times according to number of hidden layers, this is one layer, right? When you have again another layer and again another layer and another layer, and you are still multiplying something large again and again, it becomes, let's say this is 2, it becomes 200, then it becomes 2000 at this place, and eventually it will crash because it got a big number. It's just taking a computational mess, it's making a computational mess, and it's not useful either, right? So you need something that will make sure that this doesn't happen, that makes sure that everything lies within a certain range. That is where this activation functions come. Okay, so when you have x, let's see identity. First you give the input x, and then you get x, that is whatever you give inside the activation, you get the same. That is called identity. Okay, so this is absolute. There is no one uses this in machine learning. Okay, Then there is binary step. This is used for yes or no. So this 0 represents no and this represents yes. Let's say you want to deduct whether a patient is having cancer or not. 0 will say that no, the patient doesn't have a cancer. 1 will say that the patient has cancer. So that is where this is used in. This is usually used in output layer of binary classification. As I told you, we have classification and regression problem, and this is used in classification but binary classification, that has only two classes, yes or no, cat or dog. Okay, and this here is logistic. So this will give a value between 0 and 1. It's like this. Okay, 0 and 1. This is very much useful in regression. So a regression value between 0 and 1 will then be scaled up to, let's say, $100,000 to $1 million. Okay, for a house prediction. Now you have tanh function. This function is very much useful if you want to let's say if you want to ensure that there is some negativity to what you are doing. Let's say that something like a car steering angle. Okay, so you are making an autonomous car and the car steering angle is the output. It has left and right, and left can be represented as negative and right can be represented as positive value, and this value can be between -1 to 1. So this is the equation for this activation function. You do not need to remember all of this. This is simply to teach those machine learning nerds. Okay, so this is what happens when you use a tanh function. This tanh function can simply be called within one line, not even one line, within a couple of words using TensorFlow. Okay, and then arctan, and then you have rectified linear units. So this is very much useful and this is very optimized, efficient way of making a machine learning program. You will learn why this is used all over the place a little later. To simply put it, you have 0 and you have this line, and then you also have leaky ReLU. Leaky ReLU will have some negativity to it. Okay, so why you need this negativity? Like as I told you, there will be some features that will be opposite to the price. Okay, so at that time you need this, will be very useful, leaky ReLU. And let's talk about step function and sigmoid function. Yeah, so basically as I told you, step function is between 0 and 1. It's like no, yes for cancer detection or something. Sigmoid function is more like a curve, like this or like this. So this curve will have range from 0 to 1. This can be very much useful. This is tanh. So this is sigmoid. Very much useful for regression. This is for classification. This is for also multi-class classification. So not just between dog/cat. If you want to classify between n number of objects, let's say dog, cats, mice, if you have more than two object also, this same classification might be used. Let's talk about loss function and how the weights, they are produced. So in a neural, you already saw how the neural network works. Let's just say that we take one neuron, okay, and then we'll start from here. Some random weight will be initialized every time, and when it starts training, what will happen is this weights will jump down. This is cost, and it will reach here. It ran once with the data that we gave, and its weight has come to this point right here, okay, and it will keep on doing this until it reaches a global minima. At this point here, at this point, you get maximum accuracy and minimum cost, minimum loss. Okay, so when you let the machine learning model run for a long time, eventually it is going to come to this place. It will maybe skip the minimum and then it will overshoot it, or it will just come to this point. It will never get to 100% accuracy, okay. It can never find its way to minimum loss cost, okay, but it will keep trying to get there. And this can be optimized using many methods. There is optimizers like Adam, etc., but Adam works the best. What happens is, in an Adam optimizer, rather than just taking single steps like having a learning rate, this is called, this every jump is called learning rate, equal to something 0.0001, okay. Rather than having a fixed learning rate, an Adam optimizer will decrease the learning rate as it goes as it reaches the minimum, and it will start taking smaller steps rather than taking large steps, or it will take considerably small steps when compared to when initialized, when it is on epoch 1, okay, when it is training for the first time. So this is how an Adam optimizer will work. So the weights will adjust randomly. Weight will start with one number, let's say that number is 0.8 or something. According to the feature in the input layer, the weight will go up and down and up and down, and it will find its way to the weight that gives maximum accuracy and minimum loss. In simple terms, this is weight for just one something, just one feature, and it's a very simple way to represent how this works, okay. But in reality, this is how everything will be. There will be n number of features, so it will be a very complicated n-dimensional space, okay. So when, let's say, the weight is initialized here, okay, just for an example, let's say that the weight is initialized here. It will make its way here, it will come here, then again here, again it will come down. It will keep taking smaller and bigger smaller steps until it reaches a global minima, and then it will reach here. So first it will take large steps, an Adam optimizer, and then it will start taking smaller steps. This is in n-dimensional space. because you have n number of features, right? And you have various parameters that affects the weight, and there is much more to it than what a human eye can see, right? And then let's go to learning rate. Just now I told you that learning rate is one of the most important uh, parameters to be optimized. Okay, so if you have a good learning rate, let's say you are having a learning rate of 0.01 and this is having a learning rate of 0.0001. Okay, what this will do is it will take one jump, second jump, third jump, fourth jump, and then it is going to jump here, then jump here, jump here, jump here. It is never going to reach the global minimum, right? But if you take a learning rate that is pretty small, it is going to make very few steps. It is going to take miniature steps. Now it will take a long time to reach global minimum. So this is overshooting with high learning rate, and this is going to take a lot of time, and this is called confusion matrix. Confusion matrix. Just forget this population thing and all. So condition positive, condition negative, this is determined by the data. Okay, and then this is moral's prediction. Okay, so moral is predicting that it is true, and the data is also telling that it is true. So this is represented in green box. So it is the moral output and the condition, the data's output matches. So that is true positive. Okay, model is telling that it is true, but the data is telling that it is false. That means our model has failed to predict some of the data wrongly. Let's go back to the cancer detection. Just think that a patient comes in and they take some test and they feed the data to our machine learning model. Okay, and after we send the data to model, it is going to predict whether the patient is having cancer or the patient is not having cancer. In this case, the patient is having cancer, and when you cross check it with the doctor also says that yes, this data looks like the patient is having cancer. So that becomes true positive. And the test, what is the opposite of this? True negative. The data predicts that the patient is not having cancer, and the doctor also tells that there is no chance that this patient is having cancer. That is called true negative. And there are two errors. The data is predicting that the patient is having cancer. So this is somewhat okay, to be honest. Okay, you don't want someone coming in and then the data, like our model is predicting that no, he's fine, he's not having cancer. This right here, type 2 error, right? So the model is predicting that he's not having cancer. This is pretty bad for a model, okay? Especially when it comes to health sector and prediction of cancer or prediction of diabetes. This type 2 error is pretty bad. You cannot achieve 100% accuracy, as I told you. You cannot always get this or this, right? You have to compromise between the type 2 error and type 1 error. When it comes to medical sector, type 1 error is okay because they can go through another test, or they can go through x-ray, or even better x-ray, and they can consult a doctor and make sure that they are not having either they are having or they are not having the cancer or diabetes or etc. So what does a confusion matrix gives? not really much. If you want to get an in-depth view of what our machine learning is able to do, then this is pretty useful, but more or less we need accuracy. Okay, accuracy is calculated based on true positive plus true negative divided by total. So this will be like 99% if just few, like only 1% lies between these two error. Okay, so 99 accuracy means true positive and true negative, they are together combined, they give 99%. Okay, so this is accuracy. This is the equation for accuracy, calculating the accuracy. Then you have something like precision. Then what else is very important? Then you have something called, likewise you have other things like, you can say recall, summation true positive by total positive, and then you have FN score. This is so important to evaluate your model. Let's say you don't have time to check the accuracy, then check the precision, then check the confusion matrix and all. You have F1 score, that is 2 by the inverse of recall, okay, plus 1 by precision. Okay, let's just talk what is recall first. Recall is like remembering something, okay, extracting a feature of a cat or a dog, and then matching them is something called recall. If these things are not really into your mind now, don't worry, please, this is like for the nerds of machine learning, the nerds. Okay, this whole thing, I think till this, if you understood itself, is more than sufficient to go ahead and start coding. Okay, now we have some understanding of how the machine learning works. Right here we have one problem with machine learning. Okay, we have problems like underfitting, overfitting. Let me tell you what is underfitting and overfitting. This is a classification problem. Okay, you want to classify between these red dots and green X. So you are making a model, pretty simple model with very less number of neurons and very less number of hidden layers, and also very less training. Okay, you are just training it for like say once or twice. It's just simply going to make a line like this. This is not good. See, this is called underfitting. Okay, so what this means is that you have not trained enough, your model is too small, and your optimization is not proper. Okay, so these are the problems of underfitting. You really don't want to go for underfitting at all. Okay, let's see the other side. Okay, overfitting, same classification problem. You want to differentiate between O and X. Okay, now when you train the model for too many number of times, when you use a large model, it will learn to draw something like this. Yeah, it will try to differentiate even small circles that shouldn't belong to this category. So what is optimal way of separating these two, X and O, is something like this. But this is overfitting. You don't want this, you don't want underfitting. You have to train just enough, just enough training and just enough neuron or hidden layer. If you have too much of either, you're going to go for overfitting. If you don't have enough of either, it's gonna be underfitting. If we solve this for classification problem, this is two problems that occurs for every machine learning problem. Okay, not just cancer detection or classification between cats and dogs, or even for regression, house price prediction, all those things. It occurs all the time. You have to be very mindful of how you can predict between underfitting data and overfitting data. We'll be seeing that really soon. Here, this is a regression problem. These are all are data points, right? And you want a model that fits between these data points. Again, underfitting here, and this underfitting will just try to match 1, 2, 3 points and then it will end, right? This is a simple line and it has not done a good job in predicting where the points will be, right? So this is overfitting. What happens in overfitting? This will go and collect all the points, right? And then see here, it will be very noisy. That's what I'm trying to say. It will be very noisy. And what is the correct method of fitting this data? Let's say 1 or 2 data is not an issue, right? But we should be in good range. So we are missing this point, that's not an issue. If you fit every point, then it's overfitting, right? Okay, let's go to activation function, multi-class activations. Okay, so let's say that you're giving in features like R, G, P. Okay, these are going to be data from sensors. Sensor is going to give between 0 or 1. Let's say some number is going to give the sensors, and it is going to be fed into input layer. And then this pink color layer is hidden layer, and this green is output layer. So this RGB data is as matrix, it is an image. Okay, so an image is fed as RGB channels. This is pretty common when it comes to CNN. We will be seeing what is CNN, and it goes through this hidden layer, and then an output is achieved. Okay, let's say this is a car, this is bus, this is ship. Okay, and you have n number of objects to detect, and this is like 1, this is 2, this is n. Okay, so when it comes to this, can be either 0 or 1. 0 means no car is detected in the picture. 1 means yes, there's a car in the picture. Same thing goes for this. Now you can see that the output is just 0 or 1. The output is not between a range of 0.2 or it's not 0.8 or something. So this is called one hot encoding. All the data should be represented as 0 or 1 when it comes to multi-class classification. This is very, very, very important. You cannot send a string to the output. Like, you cannot teach a machine learning program to understand strings. You cannot say that CAR, this is car, this is bus. It cannot understand strings. Okay, so this is very, very important when it comes to multi-class classification, and this kind of encoding is called one hot encoding. So representing car is 0, either car is there or not, 0 or 1. This is called one hot encoding. Let's just quickly go to an example of how encoding is working. Okay, so from various sensors, just crash that car, bus or something. Let's come to new one. Okay, you're giving input right here. Okay, some input, some features, some data, something. Okay, and then the output is going to be something like 0 1 0. That means it is green. 1 0 0, then it is red, then 0 0 1, then it is blue. That's all. This is called one hot encoding. This is very useful in multi-class classification, as I said. And then this will be 0 1 0 again green. Okay, this is how one hot encoding works. So you cannot send something like red. This is a string, you cannot send it. This is not possible in machine learning. And you cannot say that red is 0.2, blue is 0.5, green is 0.7. No, this doesn't work. This doesn't exist. Okay, it has to be one hot encoded. All the strings must be changed to this. Okay, let's go ahead and fire up TensorFlow. Just a simple model here. Visualization tool. We have features, one feature, two feature. This is a classification problem. What it has to do is it has to classify between all this blue dot and all this yellow dot. Let me zoom in a bit. So we are using tanh activation. We can use ReLU or tanh or something. I request everyone to you guys should also go to this website and try this out. I will link this in the description. This visualization is made by TensorFlow. As I told you, we are using only one neuron, just one neuron. And then output is also just one neuron. Input is 2. Okay, this is having total of 2 neurons. That's all. And regularization, no need of regularization at all. Let's just keep it very simple. Let me run this. Okay, no matter how many times it is going to try, it will not be able to successfully classify these 2 points properly, because the neural network is pretty small. Okay, let me pause here, just restart. Let me increase the number of neurons. Okay, so this can represent only a line. A single line can be represented with this neuron. Now let me make 2 neurons, then it will be able to make 2 lines. The equation that this can come up with is just 2 lines, right? Yeah, so it makes something like a triangle to classify. Okay, let's restart with 3. Okay, now it will be able to make a triangle, yeah. Yeah, we got it, because we have one neuron here also. So it's able to, can you guys you should just see here, it makes one line, this makes another line, this makes another line, and this is forming a triangle. Okay, and what this does, it is mixing up these 3 to make a circle. Quite impressive, right? And we can go pretty complex with this. Let's say this is clustering, just 3 neurons. If you run this, it will be able to easily classify it. And let's go to regression. Okay, we have 2 data set here. Let me just run this with more number of neurons, and it should be pretty easily done. Let's go back to regression classification. Let's give something like this, and let's increase the noise. I really want to show you guys what happens if you take a big neural network and yes. Now if you guys see, initially it is training properly, right? Initially everything is great, but after a few while, what happens is it will not be able to, yeah, it is classifying all the blue lines. It will try to reach these blue lines also. The learning rate is pretty small, that's why it's taking a lot of time. So when you have a large neural network, it will not be able to properly make a circle, or it will not generalize properly. Simple. See this right here, it's trying to reach this point without touching the yellow orange circles. So this can make pretty complex equations to achieve its solutions. That's what this is doing. So you shouldn't have a pretty large neural network. It is waste of space. It takes a lot of time to get trained and all. Okay, so these lines, these dark lines, you can hover over these lines and see the weight. Yeah, the weight is 1.2 and 0.24. The weight is minus 0.48, and how these weights are going. Here 0.27, and this is 0. Minus 0.28. All this you can see. So you guys should go ahead and check this link out, play with this, and learn how these neural network are getting affected based on learning rate and activation, and the number of hidden layers, all these things. See, you should take a look here. So the training loss and test loss, as I said, validation loss. Okay, these were pretty consistent till this point, and then it started to get fluctuations here. Okay, but before that itself, you can see that it is overfitting. That means the data that we gave in the training data, it is fitting to it properly, but it is not going to be generalized. This kind of curve shows that. And let's go ahead and start typing in a simple code. So now let's start with cancel detection code. What are the steps you want to follow? You have to first load in the data, okay, and then you have to split the data. As I said, you have to split it into test set and training set, okay, and then you have to normalize and scale the data. What is meant by scaling the data? You cannot just throw numbers like 10,000, 20,000, or radius of curvature is 1.74 or 5.8. You cannot throw any data like that. You have to have all data between 0 and 1. That's why we have activation function. Okay, and then you have to create the model, then training the model, then evaluating more, then prediction on new data, unseen data. Okay, and then save the model for future use. Pretty straightforward. We are going to import some of the modules that we discussed before. So we are going to import pandas, numpy, matplotlib, and seaborn. Okay, this is pretty straightforward. And in order to get data inside this Google Colab, so by the way, I'm using Google Colab. This is called Google Colab. You should see my previous videos if you don't know about this. Just type Google Colab in your browser, and the first thing, just go to it and just give new notebook, and you should see a new notebook, just a blank notebook without these typings and typos and all. Okay, so the first thing you want to do is type these things and hit shift enter. Shift enter will create a new line for you automatically, or use alt enter. Okay, these are the shortcuts. Or you can go ahead and run every cell individually. You can click on code to add new cell. You can simply delete this by clicking here, delete. You can add in text in between if you want to, or you can use hash to comment whatever you are typing along with the code. This all I already covered in the previous videos. Let's just go and create a load our data. Okay, so to load our data we need to use pandas pd dot read underscore csv, and then inside this we are going to specify the location of the data. But first we need to import the data into our file. Okay, so here we are going to give this. You can simply drag and drop the data. So I have the data, all the data in this file, cancer classification, and I'm going to move it inside. Okay, one more thing guys, I will link all the notebook and also the data down in the description. This data is from my website. I'll also link that website to the data. So this is the link from where I got the data. Let me just open up that link and show you guys. So here, this is the link from where I got the data. Okay, in this link they will give all the details along with how you can along with the data. Just click this button to download the data. Okay, data folder right here. If you click this, you will download the data, or you can go to my GitHub page and get the data downloaded. Okay, let's go. We have imported our folder. Let's just type cancer classification .csv, and if you type df dot head, this should be commented. Yeah, so there we go, we get our data. Our data is successfully loaded into our notebook. Let's go ahead and close this. Now let me zoom in for you guys. Here we have mean radius, mean texture, mean perimeter, mean area, mean smoothness. We have tons of data. Okay, and this data is going to be, all the data will be used for machine learning purpose. We do not need to do any data cleaning for this part. In the upcoming videos I will do how to do data cleaning and all those things, but this data is already cleaned up for us. So this is having 569 instance. It is having 31 columns. Okay, you can type df.info. In the previous video I have shown you guys how to use pandas. So we have mean radius, mean texture, mean perimeter, and then we have 30 being 0 or MAL1. Okay, what does this mean? This means whether the patient is having cancerous cells or they are not having cancerous cells. Okay, so BNIGN tumors, okay, or non-cancerous growth in body. Unlike cancerous tumors, they do not spread. Okay, and this thing right here, that means malignant cells, they are cancerous cells. That's what this BIN0 and mal1. So if this column is 0, if this is 0, let's go ahead, scroll here. So all this 0 means that patient is not having cancer. Okay, and if it is 1, then all this data corresponds to a cancer. Simple. Let's go ahead and see what are the columns we have. Then we type df.columns. Okay, and we have mean radius, mean texture, mean perimeter, worst concavity, worst compactness, worst smoothness, then worst concave points. We have a lot of things here. Just to know how many number of columns we have, we type df.columns inside length. Okay, it shows 31, which means we have 30 features and 1 output, that is being 0 mal 1, right? That is going to be our output, that is going to be our y. Let's see how big is our data. So df.share, so we have 569 rows or data points. Then we go to count plot. We can just count how many of our data is having count plot. X equal to whatever is here. Let me just copy this. You didn't make any typos, okay? If you make any typos, then it's gonna throw you errors and it's going to take ages. Just copy paste, okay, from the data, and y equal to, yeah, y you should mention because this is a count plot. Data equal to df. Okay, done. So here I'll just convert this to light theme. Save. Here you can see that all 0 means they do not have cancer and all 1 means they have cancer, and this is the count for it. So around 225 people do not have cancer in our data, and around 350 people are having cancer according to our data, in our data. Okay, so this is a simple count plot. You can do a lot, like df.corr. I also thought what is these things in my previous video. You should definitely go and watch my pandas tutorial if you don't know what this is. Here it is going to correlate between two datas. Okay, that's what this is. If you have something like this, it's not going to be useful. What you have to do is you have to convert this into a map. Now if you take a look at this, you can see that mean radius and mean perimeter, they are very closely corresponding. Okay, and all the dark parts, they do not correspond. All the light parts, they correspond highly. So what are the things that correspond highly? Worst perimeter, right? Worst perimeter and mean radius corresponds. Mean perimeter and worst perimeter, they correspond. Then things that doesn't correspond or worst concavity and, yeah, the concavity, the radius, this thing doesn't correspond well with our output. whether they have cancerous cells or non-cancerous, so it doesn't correspond well. But things like mean symmetry, radius, this thing corresponds well with our final answer, whether they have cancer or not. But we have to feed it into our neural network and see what our neural network will be able to come up with. So let's quickly do another plot. This is my favorite plot, scatter plot. This can give you more insight of how your data looks like. Mean radius, and I want y to be what do we want it to be? Mean symmetry, and always use this. Hue is my favorite of all the tools. Okay, so I don't want to make any typos. Let's go ahead and copy this, paste it right over here. Okay, I already taught you guys what this means. I'll just cut this and teach you guys again how everything is going to come. Yeah, we need to type data equal to df. That's it. So you will see that mean symmetry and mean radius, how on x and y axis. Let me just put this thing right back. Yeah, and now you will be able to see some correlation between them, or you can see that mean radius, those who have smaller radius and smaller symmetry, they have cancer. What this means is, if the radius is small, yeah, it's after I see this data only I itself can understand why this is like so. So if the radius is small, then the concavity is more, right? It will be more bulged. Smaller radius but more high. Okay, so these people are having cancer more. Let's also add one more thing here. Let me add, we didn't add size, right? Yeah, we can vary the size of each dots here according to a variable. Let's say that we want mean concavity, and if you run this now, you can see that the bigger the small dots are having less concavity, and these blue dots are actually more concave. So now you can correlate between a number of variables like mean radius, mean symmetry, and mean concavity towards whether the patient is having cancer or not. Okay, so this is pretty useful to know the features that really matters to you, so you can delete many columns after playing with this for a little time. And then the next is box plot. So after scatter plot, my favorite is box plot. And then I want x to be this one, and then y, I want to correlate it between mean radius and see whether the mean radius actually affects anything at all. So tf, let's see this. Yeah, so when the radius of the patient with cancer is less, you can see that if the radius is more, then they have less chance of having the cancer cell. If the radius is yeah, if the radius is less, then they have more chances of having the cancer. If the radius is more, then they have less chance of having that cancer. Okay, let's quickly go. Let's like run through everything very fast, and let me finish off with a pretty easy model. Drop. We don't want this in our x, so all this x means inputs, features. So x df dot drop this and specify the axis equal to 1. I taught all of this in my previous video. Okay, I'll also go to what I'm typing here. Just give me a second. Okay, df data dot values. Okay, so x means all data, this means all features. Okay, this means all answers or everything that comes out of output. This drop means it will remove this column alone in the axis 1. Axis means downwards. Okay, and then we have to convert it into array, at least numbers. Okay, so this dot values means it will take only values, it will not take non-character, or if it is specified like if it is a blank, then it won't take. Or you just simply want to convert it into array, that's why you use dot values. You want to make sure that all this x is as a numpy array. And after this, let's run this. Okay, and then you want to split this data into test and train set. Learn dot model underscore selection import so from sklearn we want to import model selection, import test train test split. Okay, so if you cannot keep remembering these things, you just write it in a piece of paper. I have a small piece of paper, it's like a cheat code for me, so usually have it somewhere close to me, so whenever I am doing some machine learning project, I can simply take that paper and see how to import these things, or how I can come up with, you know, typing fast without going to Google. And by the way, if you type maybe like 5-6 models, 5-6 programs, then this will come naturally. You don't even have to, you know, go ahead and check Google. So we are going to use this train test split, and then if you can actually open help menu right here. Test split, we didn't run this. Okay, so now we should get some help here. LIT, yeah, it opens up here. If you scroll down all the way, there should be examples, right? np.arrange, no. Here explain x test, y train, y test, train test split. You have to copy this line. And paste it right here. No need of random state, and this can be 30. Okay, so we want to split this x and y data. To split that x and y data, this is capital X. Note that this is capital X. Okay, we are going to take x train, x test, y train, y test. This right here will return these 4 things. Okay, it's basically like tuple packing in Python. So we give x and y, x and y. We say that we want 30% of our data to be test data. So this x test and y test will be 30%, and the x train and y train will be 70%. Is x train and y train, right? X train will have all the features, y train will have the answers. And if you run this and check the size dot shape, right? And if you check it, 380 and 398. Okay, and if you check y train dot shape, yeah, same thing. So this is training data, 398, and it has just one it's going to be 0 1 0 1 0, something like 0 or 1, right? See, 1 1 0 1 0, have not have cancel, not have cancel. Okay, and if you check test dot shape, the remaining 30% of the data will be here, 171. I think you guys understood what this is. Next, as I said, you have to scale the data, because features will have values from 0 to 100 or anything. Radius will be 1.2, 10.2, who knows what. So here you can see that, yeah, the perimeter 122, but machine learning model needs only values between 0 and 1. You have to scale all the values right here, like 1000 or 1300, into something between 0 and 1. So the maximum of these values will be 1, and the minimum, if it is 0, then it is going to be 0.000. So you have to convert it, you have to scale all the values. But there is a trick to do this. You don't have to manually go and change all the values, there is built-in functions or built-in things in Python for everything. You don't have to do a lot of pre-processing. From sklearn.preprocessing, import min-max scaler, and then we create an instance called scaler equal to, and then we call min-max scaler. Okay, done. And now we have to use this scaler xtrain equal to scalar dot fit transform. Okay, for training data you have to use fit transform. I just realized that my explanation for fit transform and the scalar was not good enough, so hopefully this small clip will make it better. So I'm going to import numpy as np. Then we need to import our scalar from sklearn.preprocessing import. For this example I'll be using standard scalar. Okay, so we have imported standard scalar. Now I am going to simply create an array, a numpy array like this. So np.nan means there is no value in that. Okay, it's empty. Okay, so we are creating this np array, and now we are going to use a scalar. We are going to create an instance of our scalar, that is standard scalar, and what we are going to do is we are going to just simply fit our x data. So this right here, this is our x data, and we are going to simply fit our x and see what output we get. Okay, scalar dot fit. Okay, so now if we print our, we have to give x inside. Now we have successfully we have done fitting the x data inside using scalar inside x fit. Now if I print x fit like so, you can see that we are not getting any array, we are not getting any numpy array. We are simply getting with mean equal to true and with standard equal to true. What does this mean? Okay, let's see what fit does. Okay, we are doing fit because this calculates the parameter u and mu and sigma and saves them as internal objects. Okay, to explain this in better, okay, computes the mean and standard to be used for later scaling. So it just computes mean and standard to be used for later scaling for machine learning application. It doesn't do anything else. And there are various explanation for this, used to generate learning model parameters from training data. Okay, that's what this fit does. Now let's go ahead and do the same thing for transform. Okay, let me type x transform equal to scalar dot transform, and we are going to give x data. And if you take a look at our x transform now, see, now we have transformed our data. So this x transform, it does only transform our data between -1 and 1. Okay, so it calculates the maximum, minimum and all, and it will transform the data in such a way that a machine learning application will be able to understand, to make sure that all values are somewhere between -1 and capital 1. This scalar will standard scalar. Okay, this will be used when you are using tanh function. Okay, let's also see the explanation of transform. Parameters generated from fit method applied upon model to generate transformed data set. So first we have to fit the data, then we have to transform the data. Okay, but if you don't fit the data, then it will be used for only testing purposes. Okay, when you have when you have trained data, you have to fit it and then use transform. But when you don't have when you are using test data, then you just transform it without fitting the data. Okay, now let's go back and see what is fit train. Okay, so x fit transform, so x fit transform equal to scalar dot fit transform, and we pass in x, and now we can simply print x fit transform and see how it looks like. It should look exactly the same, but we have internal component. The internal components are with mean and with standard deviation. Okay, so these parameters will also be inside x fit transform. That is what is the difference. When you are using x train, you have to use x fit transform always. Okay, and when you are using X test, then you don't need standard deviation or the other internal parameters in the learning model parameters. You are not learning from the test data, you are learning only from training data. So this will prevent data leakage. If you fit the test data, then it will learn from the test data also. You don't want it to learn from test data, you want our machine learning model to learn only from training data. That is why we don't fit test data. Okay, so that's the difference between fit and transform and fit transform. I think I made it pretty clear, and let's jump back to the video and continue. X underscore test, okay, equal to scalar dot just transform, don't fit the data. Okay, yeah, it will get clear when I run this cell. Let's go ahead and see any one of the data. Yeah, see, all the values is converted between 0 and 1. It is in floating values. And let's see the training data, test data now. These are all features. Okay, there is 1 2 3 4 5, okay, and this is 6, so 5 into 6 30 features are represented as values between 0 and 1. The radius, the concavity, the roughness, smoothness, everything is now converted to values that a machine can understand, machine learning model can understand. And now we are going to see the test data. Yeah, it also gives a similar result. You have to use transform to prevent data leakage. Okay, let's just go with flow tensor dot keras dot models import sequential. So the type of neural network that we are going to be using is sequential. Layers, import dense, comma. Yeah, that's all. We don't need anything else. Run the cell. Now we just have to make the model. So we are specifying that our model is sequential. Then we are going to add layers to our model. I said right, hidden layers and all those layers. We are going to keep adding layers until we get the number of layers needed. We need model.add dense, and then we are going to say that I need 30 neurons and activation equal to I need ReLU activation. Okay, this is not tan H, this is ReLU, and you can copy the same line and add another layer, but we need 15 layers now, 15 neurons in this layer. Done. And then this thing is binary classification, as I said. So and for a binary classification what would be the final layer? The final layer is just one, right? Whether the person with all these features is having cancer or not. So this activation will be sigmoid. Probability that they are having cancer or not, sigmoid. And then we have to compile this model. Okay, so this is pretty standard for all model, no matter what model you are making. You have to create the model, add layers to the model, then compile the model. I'll teach you guys another method of also creating the model later in another video, but this is pretty standard. Okay, loss, as I told you, we have MV for regression problem, but for a binary classification it is binary cross entropy. Always remember this. I didn't want to add all this in theory part because then you guys will feel really tired. Optimizer, I said Adam is one of the best optimizer. There is something called RMS prop. If you guys want to try, then type RMS prop. It is also pretty good, but Adam is the most recent, and it's like a breakthrough optimizer for machine learning. And this should create a model. Okay, now we have created the model. Okay, now we have to fit the model dot fit, and then you're going to specify the training data, train, then y train, then epoch. Equal to I wanted it to run for 200 times. Okay, so this is good to go. You can run this and get a good result, but I also told you guys that there is something called validation set. If you pass validation data, the testing set, you can get the accuracy and loss scores, right? We will get the loss score, and by comparing it with using that in our graph, we can understand if our data is overfitting or underfitting. So let me just increase the epoch to 400 to make sure that this is going to give us a overfitting model. It starts running. We are getting we are around 150 epoch out of 400. So according to the size of the data or things like that, this might take a while. Okay, if your system is pretty slow, this will take a lot of time. It depends upon your internet connection. And also, let me scroll this all the way up. So at starting, it looks like we had a loss of around 63%. Okay, and validation loss is 61%. After it started to train, you can see that the loss has gone down significantly every epoch, and then its loss still came down slowly, but the validation loss, it started going up and down. It started fluctuating. So from this, you don't get anything, but you can actually plot all this into a graph. Loss is equal to pd dot data frame. Okay, what this pd dot data frame convert does is it takes say something like a data, okay, a numpy array. Okay, this will convert array or things like that into a pandas data frame, and then you can use SNS, Seaborn or matplotlib to plot that data frame. Okay, so loss is equal to pd dot data frame. I'll just go ahead and print losses for you guys to understand how it looks like. So yeah, we have loss, we have validation loss, and it is represented as numbers in a pandas data frame. Okay, we can go ahead and type losses dot plot, and you can see that the validation loss is fluctuating very badly, right? So this is definitely overfitting to the data we gave. The validation loss, it kept going down, but the validation loss, it started going up, right? So it was not getting properly regularized to all the data. How can we fix this problem? There is something called early stopping from TensorFlow. You can simply use that, but I think for now, seeing how to make this better, but for now I think we can end our session here. So predictions equal to model.predict classes. It gives a warning, but now mind, we are going to change this code in the next update. It is still on the metrics. Import classification code, and then confusion matrix. Okay, and then we are going to print classification report based on y test comma predictions. So we are going to basically compare the predictions with our true result, So this is going to print a beautiful confusion matrix in which you can see not a confusion matrix. This is going to print a classification report. You can see the precision, you can see the recall for the person who has no cancer, the person also has no cancer. I told you, right? So for all zeros we have a precision of 0.92, and for detecting the cancer we have even higher accuracy and recall, and then we have F1 score, and then we have accuracy here, macro average, weighted average, etc. And we can go ahead and make a confusion matrix really quick. Exact same thing. Okay, just copy this line of code, type it right over here. Instead of classification report, it is going to become confusion matrix, and you can see that we have true positive and true negative here, and then false positive and false negative. So this is type 1 error and this is type 2 error. You want to minimize type 2 error, and this is not a perfect model at all. Okay, so this is how you can make a model and train model and evaluate the model. Last thing I'm going to teach is how you can use this data you use this model to okay, so we are going to take something out of this. I'm taking 110th element of X test. Okay, so these are all the features right here, and then we are going to reshape it. Okay, if you don't know about reshape and all, you should go ahead and watch my previous video. And now yeah, so we just have an extra, since if you don't use reshape, it will give you an error since it needs to be in 30,1 shape. Okay, so reshape and then type 1,30. It has to be in 1,30. This is the shape that it has to be in for the model to understand. Okay, so this is what we have here, and then we use model.predict to predict on new data. So basically this is our data, right? This is not new data, but you can use the same model.predict underscore classes. Because this is a binary classification, we use model.predict classes, and then copy this line, paste it inside this. If you run this, it is telling that the patient X test 110 is predicting that he is having cancer. Okay, so let's go ahead and check, like verify whether it is right or wrong. 0. Yeah, see, we are predicting correctly. We have very good accuracy, so we are able to predict that someone with this data, obviously this data is scaled for our machine learning model, but this data is, this person is having cancer, and we can verify that by checking with our answers. So last, let me just tell you how to save this model. From TensorFlow dot keras dot models, import load model. So this line of code is for model you previously saved. Okay, model dot save, all the models should be saved as .h5. okay, so my model, I'm just naming this as my model .h5. you can name this however you want. You can name this as first model or cancer detection model, anything you want, but it must be in h5 format. If you hit run or here, when you open the file, you should be able to see this model has been created. Okay, if you want, you can download this, but once you close this collaboratory tab, once you close your Google Chrome, everything here will be lost. Okay, so make sure that you download and keep the model if you want to, and so you have saved the model. Okay, now if you want to load the model later, just use this load model from TensorFlow keras.models, and you can later model, I'm just going to name it as later model, use load model and specify the location. If it isn't like data slash, I'm just giving you an example, please understand data as, and then you have inside a data folder, if you are having this model, you have to specify its full path, or it's on the same folder for me. dot h5. Okay, and then we are now loading the model. So again, later model dot predict underscore classes, and then we pass in this piece of code to cross verify that we are able to load model properly. Yeah, so we have loaded the model as later model, and we are using the later model dot predict classes to predict if the person is having cancer or not. I think that's it for the tutorial. Hope you guys liked it. If you like it, give it a thumbs up, and please subscribe to my channel if you want to see more. If you guys didn't understand a lot of things, then you can go ahead and download everything from my GitHub and try all this for yourselves. But I am trying to make the best possible instructions to making machine learning models and playing with machine learning stuff in Python. So please support me by hitting that subscribe button. See you guys in the next video. In the next video, I'll be making a regression type of machine learning problem to predict house price. So that is going to be pretty interesting. And if you guys have any doubts, leave it down on the comment section. If you want to see more, just give me a thumbs up and subscribe, turn on the notification. Thank you for watching.